kind of urged to respond to the scarcity of existing sheltering and housing by producing architectural models that could be mass produced, assembled quickly, and sold at low prices. Among these were numerous examples of domed constructions, self-resistant structures which solve the problem of transmitting the structure's weight through their own shape. We may recall, for example, Bucky Fuller's geodesic domes of the late 1940s, the airform houses that Wallace Neff and Paul Williams designed during the 1950s, inflatables designed by Ant Farm in the 1960s, or the more permanent domes built by Paolo Soleri in the Arizona desert from the 1970s on. The Binishells feed into this tradition that we could call spatial architectures. Certainly some of these examples were inspired by the space age, yet they do it in a very unique way, using what Nicolò calls a disruptive construction technology that makes the most of an immaterial material. Nicolò's father, Dante Bini, who I just introduced, envisioned this technology in the 1960s, and he applied it widely. Today, Nicolò is pushing forward these ideals of doing the best for the most for the least, as the designer Charles Eames used to say, to meet current social, economic, and environmental needs. So in this regard, Nicolò confirms to his belief in that a great idea, his father's idea, can engender other great ideas, as we will see tonight. Nicolò Bini is the founder and president of Binishells. His educational and professional trajectory could not be more international. Nicolò holds a BA and MA from UC Berkeley and studied at the University of London and also at the Università della Sapienza in Rome. After graduating valedictorian, Nicolò worked in renowned architectural offices of London, Rome, and San Francisco. His architectural work has received many awards and has been published widely. In parallel to his professional work, Nicolò has taught at the California College of the Arts. And I apologize, my internet connection is not that stable. And also stated in his bio are the designations of Nicolò as one of the 9 of 9 coming architects by the Angelino magazine, and the reference of Forbes, that Forbes made of him in 2011 as one of the 31 names worth knowing. Nicolò's world travel trajectory helps to explain the holistic response of his designs to what ultimately matters the most, the preservation of our natural resources and the provision of a respectful and deserving existence for all. Thank you, Nicolò, for taking us on this very special trip. We will now make you the host so that you can share your screen with us. And as we put the spotlight on our host, I kindly ask you to turn off your videos and microphones by clicking on the icons that appear on the lower part of your screen as you move the mouse in that area. And once we start the Q&A, I will ask everybody to come back. So thank you, and the stage is yours, Nicolò. Thank you.
Silvia, thank you so much for this opportunity. Thank you all for joining. I'm super excited to take you through some this short presentation. The presentation is organized around 3 quotes by this gentleman who you all know, Frank Lloyd Wright. Frank Lloyd Wright has been incredibly inspirational to me throughout my career. I have many books of his, but this particular little book that I purchased when I was in college has just been filled with incredible wisdom. And I especially appreciate Frank Wright's work, or rather than his work, which I'm a huge fan of. I'm incredibly inspired by his writing. This is a person who, you know, has been called the father of American architecture, and thought very, very carefully about architecture, loved it very, very much, and considered it his life's passion. And the first of the three quotes I'm going to share with you is this very simple and beautiful one here. He says, study nature, love nature, stay close to nature. It will never fail you. And that little quote, I think, packs incredible amounts of wisdom. If you look at nature as a design inspiration, it'll teach you about proportions. It'll teach you about relevance of materials, relevance of scale, relevance of environmental relevance and cultural relevance. It will teach you how to design in so many different ways. And when you look around at the design world today, especially at the design world, you know, of architecture with a capital A, you might wonder if in fact we have lost our way a bit. If you look at some of the work of some of the greatest architects today, the question has to come up. Do these buildings relate to their environment? Do they represent a human scale? Are they mannerist works that have needless cantilevers at great expense? Are we using our resources in the most efficient and appropriate ways? This is the CCTV headquarters in Beijing by Rem Koolhaas. This second work is the Mecca Clock Royal Tower in Mecca, especially I think surprising, given that of course Mecca is such a holy site in the Islamic world, the holiest of holies, and to have this gigantic building towering on top of it, but also having it reference a completely foreign culture, seems devoid of respect for the holiest of holy sites that it sort of serves. Another building by this time by Santiago Calatrava, the Queen Sofia Art Center. This is of course an architect who's also an engineer, and therefore one might expect efficiencies, form follows function kind of elegance. And certainly it's a beautiful form, or you can argue as much, but there's a lot of needless expense, cantilevers that again seem mannerist, that don't follow from the function, that have indeed created a lot of problems for this building. Another example is a Frank Gehry, the Lou Ruvo Center for Brain Health. You might wonder why the building is shaped like this, why they went to such extent to contort the shape of the building, even in instances where it seems to serve no practical purpose whatsoever for a scientific center. This is a building called the Sharp Center by Will Alsop, that is a design school in Ontario. Again, one might wonder how this building stands up. It doesn't look like it should stand up. Is this the message that we're trying to teach in our design schools? And there are many other examples. This is on Paradise Island in the Bahamas, Atlantis. It seems absolutely absurd to create this completely foreign, introduce this completely foreign aesthetic onto this perfect island. These islands that were built in Dubai, this is the Palm Jumeirah island, the only one I think that was finished. And they've created immense environmental issues, even though they were presented as as environmental projects. And finally, the Burj Khalifa. One might think that skyscrapers make sense in very dense urban environments, but it's interesting that the very tallest skyscraper in the world should be in the middle of a desert. Why would that be? So are we, in fact, studying nature enough? Should we be studying nature more to have it teach us how better to use our resources, how better to make our references, how better to relate to our environment? The second quote I have from Wright is this one, and now we're talking about the home. Wright asks, what is the matter with the typical American house? Well, just for an honest beginning, it lies about everything. So a very damning representation or commentary on the American house. Why so damning a commentary? Well, to Write, you know, the references that are made in the sort of dream home of the Americas are all wrong, are all against the concepts that America stands for. The materials used, the detailing, the looking back instead of looking forward. And this is at the high end of the scale, but certainly this is the largest housing complex in the US still today. We can agree that at the lower end of the scale, the situation is even worse, with foreboding architecture that seems anything but relating to the function that it serves. So what is the point of architecture? What is the most important things that architecture provides us? And I feel like one could make the comment, the opine that one of the most important things is that it provides us with shelter, that is an efficient use of materials, and that it's affordable. We consider ourselves to be very savvy consumers these days, and in fact, in terms of money, our homes are the thing that all of us, whether we're at the higher end of the economic scale or at the lower end, that is what we spend most of our money on. We don't spend more money on anything other than housing. So how are we doing in terms of providing a good product? Well, from the point of view of shelter, I think one can make the argument that buildings just aren't very efficient, that we need far safer buildings to stand up to the increasing pressures that nature is putting upon us. And you know, this is true in earthquakes, fires, high winds, all of the flooding that we've seen happen more and more often all around the world. And in terms of efficiencies, I think a very damning report on construction as a whole, with 50% of our natural resources used by buildings, 40% of our energy used by buildings, 40% of our carbon emissions developed by buildings. And finally, with regards to affordability, one need only say that 1 out of 4 people in the world today is living in substandard housing to recognize that we need to do a lot of work in the construction industry. And I think as a whole, there are tremendous opportunities to improve the way we provide shelter, the way we make that shelter efficient, and the way we make that shelter, very importantly, affordable. Which brings me to the final quote from Wright. He says, I promoted plasticity as conceived by Lieber Meister, which is what he referred to, of course, Louis, that's how he referred to Louis Sullivan as his sort of mentor. I promoted plasticity as conceived by Lieber Meister to continuity in the concept of a building as a whole. If the dictum form follows function had any bearing at all on building, it could take the form in architecture only by means of plasticity, when the work is seen as complete continuity. So why not throw away entirely all implications of post and beam construction? Have no posts, no columns, no pilasters, cornices or moldings or ornament, no division of the sort. Any building should be complete, including all within itself, instead of many things, one thing. So here we can, I think, maybe better understand what Wright had an issue with in regards to the American house. He was here thinking again about a natural home, a home that didn't rely on references that were antiquated and no longer relevant, a home that was holistic, entirely holistic, one thing. And if we are to take seriously his suggestion about studying nature, then one might make the argument that nature's most essential raison d'etre, its most critical function is survival. Nature is built to survive. You know, the tigers is camouflaged with its stripes to survive, and millions of other, of course, examples that one might think of. And with regards to shelter, one might ask, what is the most elemental shelter that nature provides us? What is the most incredible example of shelter that we have as an example when we look at shelter, and when we consider that perhaps nature is critically invested in its own survival and its perpetration. To me, that is the egg. The egg is this incredibly efficient monolithic structure, 0.3 of a millimeter thick, and yet you can't squeeze it no matter how hard you try. The most internal volume with the least exterior surface area. The most efficient translation of forces along an entire, very thin, very efficient shell. Now, man has tried to replicate this perfect shape many times, and it has been generally a very challenging thing to do, because building a dome is only possible typically when using modules through a series of cantilevers that only work structurally when each sequential ring is completed. And in fact, people still today are unsure how they built the Pantheon that we're seeing here. Wright, of course, built a series of domes as well, and this is the one that he has in the Marin Civic Center. But the person actually that has built more domes than anybody else in history, I'm proud to say, was my father. And this is a dome that he built in Sardinia for a film siren and a very famous film director, the former being Monica Vitti, and the latter being Michelangelo Antonioni. And this was one of the first domes that my father built. He ended up building 1,600 of them in 23 countries. But the reason perhaps that he was able to build so many is that he devised a new way to build them. And that way turned a incredibly difficult engineering problem into something significantly more simple. What he did is he poured wet concrete on the ground over a matrix of springs and reinforcing steel, and then inflated that wet concrete through use of membranes to its final shape. Incredibly, hundreds of metric tons of concrete were lifted into position using 0.5 psi, which is very similar to the pressure one uses in smoking a cigarette. So very low air pressure results in these gigantic structures, some of them 40 meters in diameter, in a very natural way. And when the concrete sets, cures, the building is ready to be used. So a very, very efficient way of building domes. This is the interior, and you can see that incredible volumes are possible, and there are no load-bearing walls, because the exoskeleton, if you will, the dome itself is self-supporting, and doesn't require any additional beams or columns. That way of building, it turns out, is no longer code compliant due to contemporary law codes. But I've developed another way of building that results in far more fluid forms that are able to go beyond the dome, but that still use the concept and the out-of-the-box thinking that my father was an incredible pioneer for, and a mentor to me. Still using air pressure, but freeing the form from a radially symmetrical shape. We're able to arrive at buildings that are still incredibly simple to build, incredibly interesting formally, and incredibly efficient both structurally and environmentally. In the same way, the exoskeleton, the building envelope itself, does all the heavy lifting. There is no need for any columns or structural support on the interior, allowing incredible flexibility on the interior and flexibility over time if one were to want to reconfigure one's space further down the line. You can see the way that light moves around. You can imagine the way that the acoustics are affected. You can see, in a sense, the way that views are framed, and it's an entirely unique experience to be in one of these buildings. Just about everybody that I've taken this building, have sort of taken through this building, has said that it feels very womb-like. And that's a very special analogy. This is a little video I put together to illustrate how we build these structures. And I'll just go through it and sort of illustrate what's going on. Here you're looking at the foundation. We place what we call a pneumoform, which we attach along the perimeter and then inflate. Oops, sorry. I guess I can't do that. Okay, so again, this is the pneumatic formwork that is inflated. The inflation process takes just a series of hours. The foundation itself is just a slab on grade. Once the pneumoform is inflated, it's verified that it's the exact same shape as was designed. The rebound is then tied, placed. It bends, of course. It's 3/8, generally 3/8, number 3 rebar, 3/8 of an inch in diameter. So it's tied, it's verified by the inspectors, and then the entire shell is shot. That takes a day to shoot. This is a 5,500 square foot building, so relatively fast. And once the concrete is cured, the pneumoform is disengaged, can be reused, and you can see the thin nature of the structure. The proportions are actually the same as the egg, interestingly enough, but a very dynamic shape that is wholly natural. It's not organic because it's curved, like so many other sort of architects refer to organic architecture as being, but rather organic because of how it was built and how it was designed. And how it was designed has everything to do with Pascal's laws, and you know, very little to do with any architect's ideas of proportions. And in that, it's very natural. It's very pan-cultural, but also it's very efficient, both from a structural standpoint, which I'll describe why, and from a environmental standpoint. So the advantages of the technology are as follows. We use less than half the material and about half the labor. Those being the two biggest line items in construction projects in general, amounts to the structural shell costing about half as much to build. At the same time, you have a very fast process, about 3 times as fast to build that structural shell, because you're leveraging air pressure, which is a resource that we have infinite availability towards. Structural efficiency results because the shape is natural, and like the egg, it's monolithic. So what happens is that instead of translating forces in the most inefficient way possible, which is the post and beam connection, that 90-degree connection that doesn't exist in nature, and for a very good reason, it distributes forces evenly along the entire perimeter. The result is a building that, whether it's earthquakes or fires, winds or floods, just acts monumentally more efficiently. Earthquakes has a low center of gravity. Again, the weight is distributed evenly along the entire perimeter, and the entire building works to react to forces that it is subject to. In terms of fire, there's nothing to burn. It's concrete and it's very aerodynamic, so the fire tends to go right over it. In terms of flooding, there's no absorption, so long as the waterproofing membrane on the exterior is still in good shape. And in terms of high wind, again, on another level with regards to aerodynamics and the reduced impact that any high wind will have. And why is it greener? Well, the way we build buildings, it's as if we designed, from an environmental standpoint, it's as if we designed bottles with holes in them, and we wondered why the liquid volume kept decreasing. From an environmental standpoint, buildings are containers for heat, and our buildings, with all their thousands of connections, all of materials that have different R values or resistance to heat flow, are literally full of holes. And so heat very easily flows out of them. When you have a building that's one material, the same thickness from the foundation to the walls to the roof and ceiling back down to the walls, you have the perfect building envelope from an environmental standpoint. And when you insulate that envelope appropriately to the temperature zone it's in, you get efficiencies on a completely different level. We are able to reduce life cycle footprints, not only for the embodied energy of the building, because we use less labor, less material, and greener material with geopolymers in the concrete mix, etc., but also use tremendously less energy to heat or cool the building. Number of projects that we have underway. This one is for a victim of the Woolsey fire here in out in Malibu, and this is a person that lost everything and wanted to find a solution, and thankfully was put together with me. So we're building a fireproof structure for them. This is a wellness center on the Azores Islands that will have a variety of different typologies, multi-building project. This is another of the sort of accommodations. This is a conceptual project for Utah, a sort of a community that is being proposed out there. This is another system that doesn't use air pressure. In fact, it uses tensile fabrics, sort of like the spider web, if you will. And it's a new technology that we will be prototyping out in the California desert. And this is a project we hope to line up in Malibu. This is a project that was proposed for Miami Art Basel. The artwork here is from an artist called Reza. And the idea is that we had a floating pavilion, and that pavilion could serve as homes on marshlands. And the idea is that when you build these foundations as hulls, they can literally float to respond to rising water levels. And this is a low-cost housing project that we're working on in Rosarito in the north of Mexico. Again, using this system, which we call System E, which doesn't require the use of air pressure, but still results in a very strong shape, because the saddle shape, of course, is the next strongest next to the dome, and is able to dissipate forces very elegantly. But one of the advantages is that it comes with these big openings front and back, so that you can let light in, and also you can have rectangular or square windows. So there's no special equipment required the special equipment required to build this is for the construction, but it fits on the back of a truck. So it's quite efficient from that standpoint. And of course, all the special equipment can be reused. So with one truckload, one small a flatbed, you can build a village of these things. And the idea is that hopefully some of this stuff may be considered, some of these technologies may be considered eventually for housing and disaster relief. We're also looking at solutions that propose high density opportunities, or that can be 5-10 stories, but still have all the environmental, structural, cost and speed advantages that the other technologies propose. So again, going back to Wright, the idea and the major inspiration for me is nature, and how we can mimic it and learn from it in our designs, and specifically, I think in our construction, which then informs our design in a very interesting way. Thank you so much.
Thank you so much, Nicolò. I invite everyone in the audience to turn on their videos. And we have some questions already in the chat. Dennis Thompson, do you want to pose that question out loud?
Oh, sure. Nicolò, these are very beautiful. I like your presentation. And I have some technical questions. How do you draw these? Are you using 3D software? And then how do you insulate them? And then how does the permit process go for you?
Thank you so much, Dennis. Those are great questions. In terms of drawing them, we use inflation scripts in combination of softwares that we draw a plan, and then we inflate the plan virtually, and that gives us that natural form. In terms of sorry, I know the last question was permitting. What was the middle one?
Insulation. How do you?
Insulation. Thank you. So there's a number of, you could pretty much use anything, but what we recommend is closed cell urethane, which is a spray-on foam, and can be, it can have, there is a version of it which is environmental and natural. And what it does, it's probably the most efficient, as you might know, way of insulating, in terms of its compactness, but it also provides that continuity, which is critical to a thermal bridge-free building envelope. And then with regards to permitting, the one that I showed in Malibu was permitted faster than any other building has ever been permitted in Malibu. And a lot of people know that Malibu is renowned for its challenges, it being a very, very difficult place to work in for architects because it's so difficult to get permits there. But incredibly, when they saw what I was proposing, they embraced it and said, the reason that we are so difficult to get that we make it so difficult for architects to get permits in our county is that they don't want to scar the land, and they feel that these sort of whether it's a Tuscan house or whatever else, that it doesn't improve the environment and also isn't safe and isn't materially efficient. And so it was incredible because they said we were super excited about you doing the first one here, and we want to help you. And like 6 months later, after proposing the original building and actually having quite a few changes along the way, I got the permits to construct. So so yeah, so far so good. But you know, it's something new. But the important point here is that there's no new materials, and the thin shape, the thin shell structure, of course, has existed for a very long time. So everything that I'm proposing is already codified. There's nothing new about the resulting structure. The final building falls within norms. What nobody asks when you go to a permit is how to pull a permit is how you build it. And so that portion of it never really comes into question. And so I think that's the reason that I'm hoping that you know, it'll not be such an issue.
I see that there is another question. Bobby, do you want to go and pose it yourself?
I was just wondering about how the plumbing and the electrical go in and the finishing in relation to that.
Yeah, great question. Thank you, Bobby. So all the MEP is stubbed out in the foundation itself. So when you do the foundation, you have all the mechanical, electrical, plumbing. If you want, you can pre-position some electrical or all the electrical in the shell as well before adding the concrete. That is one option, and slightly less flexible than another option, which is you can drill the conduit right up into the shell, and then when you insulate from the inside, you cover it. So you have your J-box, if you will, sticking out where you need it. The mechanical systems are stubbed out again through the foundation, and then in some cases go through walls if necessary. But what we found is that all you know, it's all standard technologies can be used in fitting out the structure. In terms of finishes, there are a number of different ways that you can, you know, finish the exterior. It can be as simple as an elastomeric spray-on coating on the exterior, or as you may know, there's some very high strength sprayed on or troweled on concrete, ceramic concretes that we're also looking into. And those have some interesting properties and you know, lifetime sort of advantages over elastomeric membranes.
I have one more question about you talked about how you know, they don't ask how you build it. I mean, what kind of engineering specs do you submit to the building department?
So what we end up doing is we create a model, a single model, which is an architectural and structural model. And we create this model using these inflation scripts. From that same model, we also are able to build and design the pneumatic formwork using derivations of sail technology software. And that same model is then the one that's given to the structural engineer. And they use finite element analyses to fit out the shell with the appropriate amount of steel in the right areas. As I say, it's quite surprising how little steel is required. Generally, it's just number 3 rebar. And another, well, I'll just stop there.
It's awesome.
Thank you.
I have a question for you, Nicolò. So I guess that the refinement of the design has implied quite a lot of testing. What have you learned on site while you were doing this prototyping and testing that you could not anticipate while drawing the model on your computer or making the calculations? What is the role of failure in the development of the Binishells?
That is such a good question. First of all, this has been by far the most difficult and humbling experience of my life. I started out trying to simply replicate what my father had done and failed miserably time after time. It was ridiculously expensive, and I actually never succeeded in simply replicating what my father had done so many times. But it was a godsend because it was no longer relevant anyway, more of an academic exercise. And I started doing variations, which liberated the opportunity to go asymmetrical. And there have been incredible learnings from the failures. I've learned tremendous amounts about how air pressure works, and how one example I can give is you can imagine when you add hundreds of metric tons of weight on an inflated structure that is asymmetrical, that the tendency is for that pneumatic formwork to change shape. And that's something that one cannot have happen in construction, because that modification of the shape will result in cracks. And even though those cracks aren't structural, they will seem structural to anybody who is used to standard buildings. What we had to do is we needed to devise a way, after several failures, of applying the concrete in a way that would minimize the fluctuation of shape. And I actually worked with JBL, the rocket scientists who we built these models that were pneumatic structural models that allowed us to develop a pattern for the application of the concrete that minimized that fluctuation in shape. And also, we ended up increasing the air pressure far beyond what we needed to again overwhelm the gravitational pull of the concrete. Yeah, there was tremendous learnings, extraordinary failures, many weeks with my jackhammer in my hand, trying to undo what I had failed to do. In the end, it's been an extraordinary growing experience for me personally and professionally.
Oh, it sounds like survival through design. So Gottlieb has another question in the chat. Jane, do you want to go ahead and pose it? Well, I will do it for her. So she was wondering about the finish on the house in the Malibu property. It looked like copper, she said.
No, it's not. It's a troweled plaster on the exterior, and and sort of a smooth finish that's both weatherproof and quite resistant. It's a standard material. It can be, any color can be integrated, and the color is integral to the design. On this note, I want to, maybe you guys can think back on the building that my father built in Sardinia. He used, for Michelangelo Antonioni, he actually ground down the local rock and mixed it into the concrete, and in that way mimicked the natural color of the earth, of the area, and in so doing, you know, added another layer of contextuality.
Can I add something? I have to say that I'm very proud of you, Nick, for what you are doing. You are surpassing my shapes, which were basic circular or square only. And as I said, I am very happy that someone with your ability, intelligence, and constant, you are really able to bring the flag of Binishells forward. Thank you.
Grazie, Baboni.
I have a question.
Go ahead, go ahead.
I have a question, Nicolò, because I have seen so much of, like, let's just say, like the Turrell crater, for example, how they look at how the light will move inside the structure over many years ahead. And with the Binishells, you are able, I have seen your like, I don't know if you call that, but I would call it skylights or so. But you also have those openings. When you are planning the shape of the Binishell in its expanded form, do you calculate for the light, for the sun, and the trajectory of it forward?
Yeah, look, it's incredible, like, you know, the tools we have at our disposal these days. I can tell you that none of my things would have been possible without that kind of technology. And as well as all the structural tools, we have tools that enable us to chart to mimic the path of the sun, different types of year. And we, as part of the project, the one in Malibu was actually for Robert Downey Jr., but we proposed that that oculus, if you will, the skylight, would, you know, hit a crystal on a particular day, and incredibly, you're able to do this stuff, and that's how we designed the overhangs in certain ones of the openings. And so absolutely, there are such incredible tools at our disposal to study all of that these days, that we can, it's just amazing what you can do.
Well, Leslie.
This might sound like a very mundane question, but if the homeowner who had hired you to design a shell for them, Nicolò, wanted to have radiant heating in the floor, wanted to have solar panels, is this even possible given the technology of your structure? And would it even be necessary?
Well, it's a great question. Radiant heating, absolutely. In fact, the whole shell can radiate if you wanted to, because it's simply, you know, tubes of water that you can put into the rebar matrix.
So easy.
With regards to solar panels, our thought is, and there was one rendering that showed this, but I didn't dwell on it. in the same way that soccer balls are made of hexagons, you can have hexagonal, which there are hexagonal photovoltaic panels that can conform to the curvature of the shell. You know, in terms of, do you need them? Why not? I think it's great to have them. They even, I think, add a sort of beautiful pixelated aesthetic to the shell. So both of those things are possible, and I think very, very good ideas.
Julia Forrester has a question.
So what's the finish on the inside of the house? Is it, do you paint that insulation or the foam, or do you put plaster on top of that as well?
Yeah, you just lathe and plaster on top of that. If you want to put there's certain temperature zones which will, in which the insulation will be better placed on the outside. That's possible. There are certain ones that you put it on the inside. There are certain ones that you put it on both sides. On the case of the inside and both sides, lathe and plaster, you're set. If you wanted to put it on the outside, that's also possible, and you can expose the concrete if you want.
And I have one more question. Everybody knows concrete cracks. So you were saying you put like another layer of something on the outside to make it waterproof?
Yeah, in terms of waterproofing, there's a number of things. There's concrete additives that you can add to the concrete mix itself that whereby the micro cracking will be filled naturally. It's a product called Zypex. When the crack occurs, you can put elastomeric membranes on the outside, and those are like a elastic paint that you can put on the outside. But you have to remember that a lot of contractors have said, okay, this is actually not that difficult. It's just like building a pool in reverse. And, you know, pools are very good at keeping the moisture in. Why can't buildings?
Thank you. They're really cool.
Thank you.
Sarah has a question for you.
I was asking about the concrete content, and have you been able, what has your experience been with looking for low carbon, carbon-free approach to this?
So yeah, great question, Sylvia. Sarah, I appreciate it. So concrete gets a bad rap. It by far has the biggest carbon footprint on anything else on Earth. But interestingly, if you take a pound of concrete and a pound of wood, the pound of wood, the construction lumber, has about 10 times more embodied carbon. Concrete in and of itself isn't necessarily bad. It's just that we make so much more of it than anything else we make as a species, that it certainly has a major impact. But thank God it's around, because if we used wood only as a structure, I think we'd be in much worse shape. But obviously there's massive improvements that can be made. And geopolymers such as fly ash, which is a very difficult to get rid of byproduct of the coal mining industry, can be used to substitute cement, which is actually the polluting element in concrete. And in our mixes, we use about we use a third less cement, and substitute that with fly ash to further reduce environmental footprint. The other thing I'll say is that in a building, the life cycle footprint is what's important. The embodied energy is very important. But because buildings last for 90 years, ideally or more, the life cycle footprint is really what's important. So we have less embodied energy because we use less material and generally greener material. But the big change is the embodied and life cycle footprint, and that we reduce very dramatically because of the energy efficiency of our structures.
Thank you so much. Nancy and Stephen, do you have a question?
Yeah, I have a question. Nicolò, thank you for the presentation. Architecture is a patient search, and the fact that you're being innovative after a complete generation before you of your father's work, I think is just really touching and impressive. So thank you for that. And of course, for your father's work, that's fantastic. I don't think it's a question, but maybe you'll comment on it. So I noticed that you brought up Frank Lloyd Wright, who is obviously one of the great geniuses, perhaps the greatest American architect of the 20th century. And he definitely built sustainable works as individual pieces, Falling Water. There are many examples, but I have to question his concept of Broadacre City, where he really had an urbanistic view that you would plop down a house separately on each acre as it went into the distant future of the environment, which I think we have to acknowledge that cities are, in fact, the only sustainable way to really house large numbers of people. So if you have any thoughts on that, I would like to hear that.
I obviously I totally agree with you. I think that Wright was a absolute visionary, and I am infatuated with many of his works, and others I'm less drawn to. But what I think is inescapable is that this man was so obsessed with architecture and had such intellectual gifts, and that his basic notion and suggestion and teaching is to follow nature. He saw that there was a problem, and that he saw the solution to that problem as being as having to be inspired by nature, and that to me is why I literally carry this book around with me all the time, because it's I think absolutely spot on.
Wonderful. Does anybody else have a question? Oh, Mona?
I have one more question.
Okay, let's do Mona and then Julia.
Okay.
Mona, you're muted.
I just cannot hold myself back, so I have to ask it. Is there any chance that we would ever be able to see the place in Malibu?
I certainly, I'd love it. I think that would be amazing. He's been quite generous in some instances in allowing me to be there with people. He's very, let's put this, adverse to diseases.
Right.
And so there's been a total shutdown with my access since COVID. But I would certainly absolutely love to take a group of you there, and
After COVID.
yeah, after COVID. It's a very unique structure. He told me that he invited Brad Pitt there, or rather Brad Pitt called him and said, hey, I heard you have a Bini shell. And he said, yep, I do. And so he said, I got to come out and see it. When can I do it? And he goes, just come out on Sunday or something like this. And so Brad Pitt went out, and it was literally only the shell, the concrete shell that was up at the time. And he looked around and he told Robert it's the most important building in Los Angeles, which was, you know, quite an extraordinary thing because Brad Pitt actually knows quite a bit about architecture. But I say it because it's an impressive building when you're there. The sculptural forms are really dynamic, and my horrible photography does not capture it. And so even more so, I'd love to take a group of you out there one day.
We would take your word. Julia.
Okay, well, this is probably a gauche question, but is it really less expensive, or after, at the end of the day, after all of this installation and all the finishes, is it really more like a high-end house, or can you really do it for, you know, what per square foot would you say is the minimum that you could do it for?
You know, look, Julia, I think it's a great question, and I don't think it's at all gauche. What we are proposing is an exterior structure, right? And that structure can be fitted out in a number of ways. Plus, we have a variety of systems, one of which addresses low-cost housing and another that doesn't. But the building itself, the structural shell, is immensely affordable. And once that building is fitted out, it can then become anything you want it to become. But we are shooting towards, you know, it's difficult to talk about cost because cost depends on terrain, local material and labor costs. But when I say that the shell costs half as much, and that in our more simple systems, there really isn't anything peculiar in terms of insulation or windows, doors and openings, or waterproofing to our systems versus others that would, you know, make a delta in the cost. I truly think, and this is my whole reason for starting this company and following in my father's footsteps, is that I was fascinated with the challenge of low-cost housing, specifically in the developing world, but everywhere. And that's what I sort of focused my studies on. And I think that our new system is a very relevant solution. Even if you take away the environmental and structural safety advantages, I truly think that there's nothing else on the market that is as affordable. That needs to be borne out. So, but I wouldn't say it otherwise.
Great, thank you so much.
Well, thank you so much, Nicolò. This sounds very promising as we, you know, the world's population keeps on growing. There are more and more people displaced. As you said, 1 out of 4 people live in poverty today. So this is a really promising solution, and we look forward to its implementation across the world in following, of course, your father's applications. We look forward to its implementation globally. I am very thankful, and I think that we all are, for this amazing presentation. It has opened our eyes in many ways. I stick to the fact that, you know, this is a great example, an inspiring example of surviving through a very inspiring goal. So thank you for that as well. Okay, well, we are a little bit over the hour. And you might be already exhausted with all of our questions. So thank you so much. We look forward to seeing you soon, and we look forward to visit one of these shells soon.
Thank you.
Thank you. Bye now.
Wonderful.
Thank you.
Thank you.
Thank you so
Thank you.
much.
Bye. Thank you. It was marvelous.
Thank you.
Mhm.
Thank you.
Thank
Thank
you.
you.